So this is a third topic. It's about the stoichiometry, and this is about the reactant and the product, the balance between those equations. So let's look at the statement here. The white color in the fireworks is caused by this phosphorus. Okay, P4 is reacting with an oxygen in the air to produce phosphorus oxide. So write down the balanced chemical equation. So that's the first thing that you need to do. So A, what this statement is showing me is P4 is reacting with O2. That will give P4O10. So let's look at the balance between the left hand side. The P4 on the left and P4 on the right. So they are balanced. Whereas on the right there is a 10 oxygen atom. There's only 2 oxygen atoms, so you gotta multiply by 5. So this one completes the balance. It's pretty easy to do. And then this one is actually more trying to use a concept called what is called the unit conversion. So let me try to explain it here. So let's look at the second problem, which is BCD. Is pretty much a similar problem pattern. How many grams of oxygens are needed to combine with reacting the P4? And that's a gram. Okay. Sometimes reacting from oxygen to grams, how many grams of P4O10 will be produced? And to produce such amount of that, how many grams of P4 are needed? So these are the conversion. And then I like to kind of give you a concept about what we call the unit conversion, and this is very, very important. So in a way, so this is I like to give this is a little different one. So this is what you want. Let's say this is a quantity that what you want. And then this is what you start with. Okay, so there are many examples here. So for example, the case for the B as an example, you start with 6.85 grams of P4, right? And then you want to use this reaction that you write here to know, do you want to know oxygen and the grams? So grams of oxygen, and you want to know what's the number, right? So what's the relationship between these two? And to do that, all you got to do is, essentially you have to multiply a bunch of ones. And typically it involves in many cases just continue to carry out and units of the one. The unit conversion is shown up here. And then when I say the 1, what do you mean by that? Right? So multiply by 1. And then this one is essentially multiply by what you start with some other compounds that you can do, and then you can continue to do multiply the one that the unit that is pretty much same up and down. So the meaning of what do you mean by 1, quote unquote, which is a unit, is something that you can write it up here. So so let's give an example of a 1 here. So example of 1 here is is if you look at here, it takes 1 mole of P4, 5 mole of O2. This is an example of 1, right? And also, this is the same thing that if you calculate the atomic mass, and 1 mole of P4 is 123.9 gram of P4. Okay, and then 5 moles of O2, oxygen, so 5 times 32 grams of O2. So that's the corresponding 1-and-1 correspondence. So that's I can do the same thing. So same thing here. Another example that I can choose is 5 O2 5 mole O2, and then let's say 1 mole P4O10, and that 1 mole corresponding to P4O10 is 283.9 gram, and the 5 mole is 5 times 32 grams of oxygen. So you can this unity ratio is defined from the way that the reactions are balanced here. Okay, so let me go ahead and start to solve this specific problem here, right? So let's say how many grams of oxygen. So I want to know grams of oxygen. This is what I want to know, but I start with 6.85 grams of P4, and then I need to multiply a bunch of ones, but that will eventually change it from grams of P4 to grams of oxygen. So 6.85 gram per P4. So there's actually another example that you can use. This is from the reaction, but from the molar mass, right? This is from the reaction. From the molar mass, for example, 1, the bottom part and the upper part in the fraction is the same. 1 mole of P4 is same as 123.9 grams of P4, right? So this is that's the meaning that the denominator and the numerator is the same quantity, so we can say so that's another unit conversion factor. So my choices here is I want to get rid of what you start with, and that start with is a bottom part, so you can delete this one in this series of calculation. So I want a grams of P4 at the bottom, and then a mole of P4, and 1 mole will weigh 123.9. Okay, so by doing so, the grams of P4 quantities are gone, and I'm shifting my focus to the moles of P4. And so therefore, I want to use another unit conversion factor, but this time I want to change from mole 4 to the quantity that I want is oxygen 4, so mole O2 is a second conversion factor. And where do I find out? Between P4 here and oxygen 4, 1 P4 will react with 5 moles of oxygen molecule, or molecule. 1 molecule of P4 will react with 5 molecules of oxygen molecule. So 5-to-1 ratio. So by doing so, once more, this is gone now, right? And then now your focus is shifted to the moles of O2, and then this is now, naturally, I want to write moles of O2 change it to grams of O2. And 1 mole, how many times does it weigh? 32 grams of O2. Okay, so by doing so, finally, you got this one goes away, you have this one, the grams of O2, which is the grams of O2. So that's a number that you will carry out, starting from where you started it, and start to carrying out a series of unit conversion. So just looking at the numbers settling down, 6.85, 1 over 123.9, 5 over 1, 1 over 32, and that will give me 8.85 grams of O2. So that will be the answer for the answering the number B here. So number C, so it's the same thing. You remember what you want, where you start, and this is how you're going to write this kind of conversion here. So what do you want? I want grams of P4O10. So that's the phosphorus oxide. And we'll start with 8 grams of O2. So what I will do is I'm going to write grams of O2, mole of O2, right? And mole of O2, mole of my choice is P4O10, and then mole of P4O10, grams of P4O10. So by doing so, you can see that surviving term, once again, is this term, which is same as shown up here, right? And then let's just start to filling the numbers now. Okay, so 1 moles of O2 weighs 32 grams of O2. And based on the reaction, oxygen, it takes 5 moles of O2 molecule to produce 1 mole of P4O10. And 1 mole of P4O10 will weigh 283.9. So if you multiply everything, you will get 14.2 grams of P4O10. Okay, so that's how you can convert from one quantity over the other. So this is based on the, I guess, the molar mass definition, and this is based on the reaction that is shown up here, right? And then you can convert that. So number 4. Okay, so what do you want? I want grams of P4. Where do you start? 7.46 grams of P4O10. Okay, and so therefore I want to get rid of grams of P4O10, right? That's how you want to do it. And conversion of gram to mole P4O10. Mole P4O10, mole, what do you want? P4, then mole P4, grams P4. Okay, and we just have to need to plug in the numbers there. So 1 moles of P4O10, that weighs 283.9 grams. Okay, and then based on the reaction, that's what 1 to 1, so it is a 1 over 1, and the 1 mole will weigh P4, where is 123.9. Okay, so having done, So 7.46, 1 over 283.9, 1 over 1, 123.9, the 1. Okay. By doing so, you will get 3.26, and the last surviving term, same as before, this one is surviving it. That's what you wanted, right? So same matching it. So gram P4. Okay. So that's how you can convert these units. So as a recap, I want you to remember, and the molar mass gives the moles, and the mass is the same quantity depending on the species that you choose. And also how many molecules of reactants and produce having a one-to-one correspondence based on the definition of what we call the reaction here. And that's how we can use it as a conversion factor. Thank you for listening. And actually also you can see that this is much more cleaner version of the answer, and you will also find in your answer key posted on LMS.